All right, this is the next video in our work on quadratic functions, specifically looking at systems of linear and quadratic equations. And here, this is a challenge in a real-world connection problem. And I encourage you to pause this video and try it on your own, and then check back in and see how you did. So here's the scenario. A pelican flying in the air over water drops a crab from a height of 30 feet. The distance that the crab is from the water as it falls can be represented by the function c of t. So c for crab equals negative 16t squared plus 30, where t is time in seconds. To catch the crab as it falls, a gull flies along a path represented by this other function, negative 8t plus 15. So can the gull catch the crab before the crab hits the water? So in other words, will they intersect at a height above 0, right? So if they intersect at a height above 0, so let's model this here. And I am not going to actually graph the actual parabolas or the actual functions here, but maybe we have something like this, and maybe we have another something like this. If they intersect, so this is the gull and this is the crab, that means it's at the same height at the same time, which means the gull will be able to catch the crab, as long as there's no horizontal distance between them, but we're making things a little bit simpler here. Alternatively, I suppose they could intersect down here, which means that the two paths the animals are following intersect, but that would mean that the gull wouldn't be able to catch the crab because it would be underwater, and we're assuming we're being asked, can the gull catch the crab before it hits the water? Okay, so if we have the solution I have drawn right here, the answer would be no. The gull would not be able to catch the crab before it hits the water. So anyway, we have to find the intersection point. So let's go ahead and do that. So I'm going to write things as y equals negative 16t squared plus 30, and our second y is negative 8t plus 15. You saw me leave some space just to help me combine like terms together. I'm going to do a big subtraction, and I'm doing that because I want my y's to eliminate. Okay, so I have a 0 on the left. Negative 16t squared minus 0 is 0. And this is a 0t up here, so we have a 0t minus a negative 8t, so we have a plus 8t, and 30 minus 15 is 15. So it looks like there's, it's either not factorable or it would be challenging to factor. So I'm going to go straight to the quad formula on this one. It doesn't look like there's a GCF, by the way, to simplify things down. So I have a is negative 16, b is 8, and c is 15. So we're solving for t, for time, equals negative 8, negative b, plus or minus a big square root, b squared 64 minus 4 times negative 16 times c, all over 2a, 2 times negative 16. All right, we can get rid of these negatives right here. Those turn into positives. So we have a t equals negative 8 plus or minus 64 plus 4 times 16 times 15. That gives the square root of 1024, and that's a perfect square, so that's going to be nice and friendly, all over negative 32. Okay, so the square root of 1024 is 32, so we're going to have some nice simplifying to do. Negative 8 plus or minus 32 all over 32. So let's start our double pathway. And so we have a negative 8 plus 32 all over 32 is 0.75. And then a negative 8 minus 32 all over 32 is a negative, I think negative 1.25. Negative 1.25. So we are going to ignore this point because that's back in time. Okay, so that's 1.25 seconds before the pelican dropped the crab. So that doesn't make realistic sense in this scenario. So we are going to be working with a t of 0.75. Okay, so now we just have to figure out how high the crab will be at that time. Okay, so we are going to bring a couple things down. Let's bring this down here. And let's bring our 0.75 over as well. And so let's just find the height of the gull at that moment in time, which would be the same as the height of the crab at that moment in time, because the fact that we've solved for t means there is an intersection point. Okay, so g of t, the height of our gull, equals -8 times 0.75 plus 15. Let's see what we get. That turns into -6 plus 15, which is 9. Okay, so what that means is the crab and the gull meet. So that's good news for the gull, I guess, right? Bad news for the crab. And the time that they meet is at 0.75 seconds, and the height that they meet is at 9, this is feet, right? 9 feet above the water. Okay, so there would be our final answer to this particular problem. And that's a good place to stop.